We can solve linear programming problems by graphing. For example, minimize z equals x plus 2y, subject to x plus y is greater than or equal to 10, 2x plus 4y is greater than or equal to 32, x is greater than or equal to 0, and y is greater than or equal to 0. We start by graphing each inequality. Starting with x plus y is greater than or equal to 10, we need it in slope-intercept form, so we subtract x from both sides to get y is greater than or equal to negative x plus 10. That means the y-intercept is 10, and the slope, or the coefficient of x, is negative 1. So we start at 10 and draw a slope of 1, so go down 1, right 1, to make a slope of negative 1. Then we can draw the line. Next, we graph 2x plus 4y is greater than or equal to 32. We subtract 2x from both sides to get 4y is greater than or equal to negative 2x plus 32. Then we divide each term by 4. To get y is greater than or equal to negative 2 over 4 reduces to negative 1/2. X plus 32 over 4 is 8. So the y-intercept is 8 and the slope is negative 1/2. So from the y-intercept of 8, we go down 1, right 2, down 1, right 2. And then we can draw this line. Now the last two inequalities are x greater than or equal to 0 and y greater than or equal to 0. So these two inequalities force our region to be in the first or the positive quadrant. And the rest of our feasible region is bounded by these other two inequalities, and we choose whichever one is greater since both inequalities are greater than or equal to. And for the feasible region, we want where the inequalities overlap. So I'll trace that region in blue. We have this line for x greater than or equal to 0. There's the next part of our feasible region. We trace this line next. From that connecting point, and then we have the line y is greater than or equal to 0. So this blue line bounds our feasible region. So now to minimize z equals x plus 2y, we're going to use the corner point theorem and test the corner points for this feasible region. The first corner point is 0, 10. And now we plug this point into z equals x plus 2y. So we get z equals 0 plus 2 times 10, which is 0 plus 20. So z equals 20. Next corner point of this region is the intersection of the two first inequalities, which occurs at 4, 6. So plugging that in would give z equals 4 plus 2 times 6, which is 4 plus 12, which is 16. And then last corner point of this region is at 16, 0. So z equals 16 plus 2 times 0, which is 16 plus 0, which is 16. So the minimum value for z equals x plus 2y is 16, and it occurs at both 4, 6 and at 16, 0, which means it occurs along that entire line segment.